Imagine this. One day you walk into a hospital, not for a transplant from a donor, but to pick up a brand new kidney that was printed. Yes, printed, just for you. No waiting lists, no donor rejections, just a few scans, some synthetic bio-ink, and a machine that builds body parts like it's assembling an IKEA bookshelf. It sounds like sci-fi, but it's not. Welcome to the world of 3D printed organs, where medicine, engineering, and imagination collide. Let's rewind a little. The idea of printing body parts started as something outlandish. When the first 3D printer was created in the 1980s, it was used for plastic parts and prototyping industrial components. No one was thinking about printing hearts or lungs. But then bioprinting came along. Scientists discovered that you could load 3D printers with living cells, yes, actual cells, and layer them like ink on paper. Suddenly, it wasn't just plastic. It was human tissue. The first big breakthrough came in 1999, when researchers at Wake Forest Institute for Regenerative Medicine printed a synthetic bladder using a patient's own cells. This was revolutionary. It meant the organ wouldn't be rejected by the immune system because it was built from the patient's biology. Fast forward to today, and scientists are experimenting with everything from cartilage and skin to miniature livers. And that's just scratching the surface. But let's step back. Why is this even necessary? The answer is grim. There are more people who need organ transplants than there are donors. According to the World Health Organization, someone dies every hour due to the shortage of organs. In the US alone, over 100,000 people are on transplant waiting lists. It's a crisis. 3D printed organs could solve it. Here's how it works. First, doctors take a scan of the organ that needs replacing. They create a digital blueprint. Then, using a material called bio-ink, a gel-like substance made from the patient's cells, they feed that blueprint into a bioprinter. Layer by layer, the printer builds up the structure of the organ. It's slow, meticulous, and incredibly complex. Blood vessels have to be formed, cell types have to be arranged just right, and the organ needs to be strong enough to function in a living body. There's a catch, though. While we've made impressive progress, we're not printing fully functional hearts or lungs, yet. The technology is still evolving. Researchers can print organ tissues and simple structures, but printing something as complex as a heart with working valves, chambers, and a circulatory system is a whole different challenge. That said, in 2019, scientists at Tel Aviv University printed the first tiny, beating 3D printed heart using a patient's cells. It was only the size of a rabbit's heart, but symbolically, it was monumental. What makes all of this so compelling is that the process could eliminate the need for donors entirely. Imagine a future where your medical file includes a 3D scan of all your major organs. If something fails, the hospital just prints you a replacement. No waiting. No risk of rejection. No black market trafficking. Just a personalized, on-demand organ shop. Let's look at some real-world examples. In 2021, researchers in Spain successfully implanted a 3D printed airway into a patient. The airway, built from synthetic materials and stem cells, integrated with the patient's body over time. In another case, a young man received a 3D printed ear built from his own cells after an accident. These aren't distant dreams. These are happening now. And it's not just humans. Scientists have printed animal organs for testing. Pigs, for example, are often used because their organs closely resemble human ones. Researchers are working on printing pig hearts, then using gene editing to make them suitable for human transplant. It's a bold move, and one that blurs the line between biology and technology even more. Still, there are major hurdles. One of the biggest is vascularization, the process of creating blood vessels inside the printed organs. Without proper blood flow, the organ dies. This is a massive engineering and biological challenge. Some labs are trying to solve it using sacrificial bioinks that dissolve after printing, leaving behind hollow channels for blood. Others are exploring how to coax the body into growing its own blood vessels post-implantation. And then there's regulation. The FDA and similar bodies around the world are grappling with how to classify and approve 3D printed organs. Are they devices? Are they biologics? Are they both? Each classification comes with different rules, trials, and legal implications. It's uncharted territory, and the law is playing catch-up. Ethics is another big concern. Who gets access to this technology? Will it be affordable or only for the wealthy? Could it be hacked or misused to create enhanced or weaponized organs? These are questions we have to face as the technology becomes more advanced. There's also the issue of identity. If your liver is printed and replaced, are you still fully you? What if 60% of your body is printed over time? Are you still human or something new? These philosophical questions don't have easy answers, but they're not new. They echo the ship of Theseus paradox. If you replace every part of a ship one by one, is it still the same ship? Apply that to the human body, and you're left with a chilling but fascinating thought. Even religious and cultural groups are starting to weigh in. In some traditions, altering the body so radically could challenge beliefs about the soul, the afterlife, or what it means to be human. As these technologies become real, society will have to reckon with questions we've never had to ask before. Let's not forget the economic impact. Entire industries could be transformed. Organ trafficking might become obsolete. Hospitals would need fewer surgical teams. Prosthetics and implants would evolve rapidly. Even pharmaceuticals could change. Imagine testing drugs on printed organs instead of live animals or humans. And education? Medical students might one day practice surgeries on printed organs that mimic the real thing. It's a game changer for training the next generation of doctors. There are even wild possibilities being explored. Some researchers are toying with the idea of printing hybrid organs, mixing human cells with animal or synthetic components to create super organs that could outperform the originals. Think kidneys that filter better, lungs that handle pollution more efficiently, or hearts that never suffer from disease. And what if we start printing organs not just to replace what's broken, but to upgrade? That opens the door to transhumanism, the belief that we can and should use technology to enhance the human body beyond its natural limits. It's controversial, but it's gaining traction. Of course, for every bold leap forward, there are risks. What happens if a printed organ fails suddenly? What if someone tampers with the blueprint? What if corporations start patenting organ designs, creating monopolies on human body parts? These are real fears, and the ethical framework has to evolve as fast as the technology. Still, the potential benefits are enormous. Lives saved, suffering reduced, medical costs lowered. Imagine a future where organ failure is just a minor setback, something you fix with a trip to the print lab. It sounds surreal. It sounds impossible. But we're closer than you think. In labs around the world, researchers are working tirelessly to bring this vision to life. And someday soon, getting a new liver might be as routine as getting a new pair of glasses. In the end, maybe the most mind-bending thing isn't that we can print organs. It's that we've become the architects of our own biology. We're no longer just fixing the body. We're building it, piece by piece. And in doing so, we're rewriting what it means to be human. So next time you walk past a 3D printer in an office or a school, take a moment. Because the future of medicine might not be in a bottle or a scalpel. It might be humming softly in the corner, printing out the future of life itself. If you were fascinated by the future of medicine and love diving into topics that sound like science fiction but are actually science fact, don't forget you. Smash that like button, subscribe for more mind-blowing content, and hit the bell icon so you never miss a new episode. Your support keeps this channel alive and growing.